Welcome to Funimation 3D, where science is everywhere, and it's way more fun than you think. Quick question for you. Have you ever rubbed a balloon on your head, and suddenly your hair went, whoa, straight up like a porcupine? Or you took off a sweater and heard a tiny crackle, like krr, and then zap? A little shock? How is this even possible? Is your hair secretly alive? Is the balloon doing magic? Or is there an invisible science trick happening right above your head? Today we're exploring static electricity, the sneaky kind of electricity that loves to surprise you. Let's start super simple. Everything around you is made of tiny building blocks called atoms, and inside atoms are even tinier pieces. Two of those pieces are very important today: protons and electrons. Protons are like little plus buddies. They stay put. Electrons are like tiny, speedy minus buddies. They can move around more easily. Now here's the key idea. When something has the right balance, it feels normal. But when something gets too many electrons or loses some electrons, it becomes electrically charged. Let's make it kid simple with an analogy. Imagine electrons are tiny marbles, or even better, invisible stickers. Sometimes, when two things rub together, some invisible stickers jump from one thing to the other. One thing ends up with extra stickers. The other thing ends up missing stickers. And when that happens, the fun begins. Static electricity is when those charges stay in one place for a while. Static means not moving around much. It's like electricity that's stuck, until it suddenly decides to move all at once, and that's when you feel a tiny zap. So why does hair stand up? Your hair is made of lots and lots of strands. When you rub a balloon on your hair, the balloon steals some electrons, or your hair gives electrons away, depending on what you rub and what it's made of. After rubbing, many hair strands end up with the same kind of charge. And here's a rule that never gets tired. Same charges push away, opposite charges pull together. Think of it like magnets, but invisible. If all your hair strands have the same charge, they start acting like they are all saying, "Too close, back up!" So they repel, meaning they push away from each other, and when they push away, they don't stay flat. They lift up and spread out. That's the hair standing up moment. Boing! Now what about a balloon sticking to a wall? That one is super cool. When you rub a balloon, the balloon gets charged. The wall is usually neutral, meaning it has no extra charge. But when the charged balloon gets close to the wall, the balloon can make the wall's charges shift just a tiny bit. The wall becomes slightly opposite right where the balloon is close. Opposites pull together, so the balloon sticks for a while, like it has invisible glue. And the little zap you feel from a doorknob? That's when your body builds up charge, usually from walking on carpet or sliding on a seat. Your body holds onto that charge, and when you touch metal, the charge suddenly jumps. Zap! That jump is a tiny spark. Okay, now it's time for the best part. Experiments. Remember, ask a grown-up to help, especially if you're using scissors, a sink, or anything breakable. Also, no outlets, no flames, and no metal tools for these experiments. We're keeping it safe and awesome. First experiment. Balloon hair surprise. You will need one balloon, and either your hair or a wool sweater. If you don't have a sweater, a dry t-shirt can still work, but wool is extra good. Step 1. Blow up your balloon and tie it. Ask a grown-up if you need help. Step 2. Make sure your hair is dry. Static electricity loves dry hair. Step 3. Rub the balloon on your hair. Rub it back and forth for about 10 seconds. Not too hard, just like you're polishing it. Now, slowly lift the balloon up above your head. What do you see? Do some hair strands chase the balloon? Do some stand up like a funny hair monster? If it works, you'll see hair reaching up, and you might even hear tiny crackling sounds. If it doesn't work right away, try again. Rub longer. Try a sweater. Try a different spot. And try in a dry room. Sometimes humidity, which is water in the air, can make static weaker. Now for a fun twist. After you rub the balloon, bring it close to small pieces of paper, like tiny paper confetti. Not big sheets, tiny pieces. Hold the balloon near the paper and watch them jump up like they're alive. They might hop and dance, then fall off. That's static electricity pulling them in. Ready for experiment number 2? This one looks like real magic. Second experiment. Bend water with a balloon. You will need a balloon and a sink. Ask a grown-up to help with the water. Step 1. Turn on the faucet just a tiny bit so you get a thin, steady stream of water. Not a big splash. A skinny stream. Step 2. Rub your balloon on your hair or sweater again for 10 to 15 seconds. Step 3. Slowly bring the balloon close to the stream of water. Don't touch the water, just get close. Now watch carefully. Does the water stream bend toward the balloon? If it does, that is amazing. Because water is not alive. It's just water. But the charged balloon attracts parts of the water molecules, and the water leans toward it like it's being pulled by an invisible hand. Try moving the balloon left and right. The water should follow, like a tiny water snake. If your stream is too thick, it might not bend. Make it thinner, and rub the balloon again. Now let's do a quick Try It 6 challenge. Pause your experiment and test this. Can you make the water bend more by rubbing the balloon longer? Try 10 seconds, then 20 seconds, then 30 seconds. Which one bends the water the most? If you can, tell a grown-up your result like a real scientist. My best bending time was 20 seconds, or 30 seconds worked the best. Now, let's do 2 myth-busting questions. You answer in your head, and then I'll reveal the truth. True or false? Static electricity can't happen on a rainy day. Think, true or false? The answer is false. Static electricity can still happen on rainy days, but it's usually weaker. Why? Because when the air is wet, tiny water droplets help charges leak away. Dry air is like a sticky room that holds charges in place. Wet air is like a slippery slide that lets charges escape. So static can happen, but it may be harder to make hair stand up when it's humid. Second mythbuster. True or false? Rubber creates electricity all by itself. What do you think? The answer is false. Rubber doesn't make electricity from nothing. Static electricity happens because electrons move when 2 materials rub together. Rubber, like a balloon, is good at holding onto extra electrons once it gets them. That's why balloons are great for static tricks. But it still needs rubbing with something else to move those electrons around. Now let's connect this to real life, because static electricity is around you all the time. Here are some everyday moments you've probably seen. 1. You pull a sweater over your head and your hair gets messy and floats. That's static. 2. You slide off a car seat or a plastic chair and then touch a door handle. Zap. That's static jumping away. 3. You pet a cat or a dog in winter and their fur crackles a little. That's static too. Poor kitty might look surprised. 4. You rub a balloon and it sticks to the wall. That's static attraction. 5. You take clothes out of the dryer and socks cling together like they're best friends forever. That's static making them stick. 6. You walk on carpet with socks, then touch metal. Zap. Tiny spark. So why is static stronger in dry air? Because water in the air is like a helper that carries charge away. In dry air, there's less water, so the charge stays on your body, your hair, or the balloon longer. That means bigger static effects. That's why in winter, when air is often dry, you might get more zaps and crackles. Now let's make sure you truly own the science. Here's a mini recap, spoken quick and easy. Static electricity is charge that stays stuck for a while. Electrons can move when 2 materials rub together. If something has extra electrons or missing electrons, it becomes charged. Same charges repel, so hair strands push apart and stand up. Opposite charges attract, so a balloon can stick to a wall or pull paper. Dry air makes static stronger because charges don't leak away as easily. And now you know the secret behind the hair monster balloon trick. Before we go, here's one more fun challenge. Try your balloon experiment with different materials. Try hair, a sweater, a blanket. or even a clean, dry towel? Which one makes the strongest static? And can you make paper pieces jump from farther away? That's you thinking like a real scientist. You test, you compare, and you learn. Thanks for hanging out with Funimation 3D today. If you had fun, please like the video, share it with a friend who loves science, and subscribe to Funimation 3D for more fun facts and cool experiments for kids. And tell us in the comments, what experiment worked best for you? The hair stand-up trick or the bending water magic?